Bless you.
Bless you. Bless you.
Gabriel.
I got number 4, but the way they worded it was kind of confusing.
The perimeter of a square is 4 times as great as the length of any of its sides. Determine if the perimeter of the square is proportional to the side length.
I mean, I got it, but the way they worded it made it confusing.
Okay. Squares have
4 sides.
4 sides that are
Equal.
equal.
Yeah, I got that.
Do you have to do any math?
No.
No. It is?
Yes, it's proportional.
Good.
It's just the way they worded it. I don't
They're
know
trying
if
to
some
confuse you.
people- Yeah, I don't know if some people got confused, so I was just pointing that out.
You should know that a square is proportional. Yes.
I didn't get number 11.
Number 11. An airplane is flying at an altitude of 4,000 feet and descends at a rate of 200 feet per minute. Determine whether the altitude is proportional to the number of minutes and explain your reasoning. Ben.
It is proportional because every minute it descends the same amount of feet. No. No?
Explain it to me again.
Since it starts at 4,000 feet, and it's proportional because it goes down the same amount of feet per minute. I think.
Okay. So if it goes 1 minute, how far does it go down?
200 feet.
2 minutes.
400 feet.
3 minutes.
600 feet.
Can a plane descend at 0 minutes?
No.
No. So it is
Proportional because
not proportional.
What?
You can't. A plane cannot go 0 minutes.
What if it's on the ground?
Hmm?
What if it's on the ground?
Ooh. Well, it does say that it's in
It's already in the air.
Okay.
Megan.
the back of the book, and I both, it said it could have started at 4,000 and 0, but it still doesn't pass through the origin, so it's not proportional.
Right. It's already in the air. If it didn't say it was in, you didn't know if it was in the air or on the ground, totally different story. But Megan's right. Since it's already in the air, it's already at 4,000. You can't start at 0, 0. Does that make sense? Okay. Other questions? Wunderbar. 12.6.
12 means 7.1.6.
Yeah, 7.1.6, sorry. Seven point 1.6, solving proportional relationships. Once you have that notebook labeled, we're going to go to page 55. Page 55. Ellen, will you tell us about Katie, please? Great. So Katie and her friends are going to the smoothie store. It's 2 for $5 today. what would that proportion be underneath it? How many dollars? Julia Gill? $5 over 2 smoothies. Fill that in. $5 over 2 smoothies. Simple Pimple?
That's nasty.
Sophie Karras, tell us about the next part of Katie's predicament.
Suppose Katie and her friends buy 6 smoothies, or something the ratio that compares the cost to the number.
Okay, so right now it's $5 for 2 smoothies. And how many smoothies do they want now? Ellen? They want 6. Alright, how did I get from 2 to 6? Well, I multiplied by 3. So if I multiplied by 3 on the bottom, I have to do what to the top? Nicholas? Multiply by 3 again. Whoops. 3 times 5 is? Go.
15.
How much money are 6 smoothies? Go.
$15.
$15. You should remember this from October, November. Okay. A couple of you got the question wrong on the test about how to. It was the pitchers of iced tea, I think. Is that what it was about?
The one with the glass.
The glasses. A couple of you got that one wrong. All right. You got to shrink down your ratio to the smallest form you can. If you can't go from 5 over 2 to get your unit rate of 1, you just have to scale up. Okay? So this process right here is called scaling up because you're moving your numbers up. Some of you have been doing that on Khan Academy. I've seen you do scaling. So if you hear the word scaling, this is what you're doing. You're moving your numbers up. Okay? Is the cost proportional to the number of fruit smoothies? Explain your answer. Are these two ratios proportional? Megan Fabro.
Yes.
Yes, can you explain why?
Because if you two goes into 6 3 times.
Good.
And 5 goes into 15 3 times.
So if I didn't have all this work up here, you would be able to tell me that 15/6 you can scale down to, or reduce is what you're used to, 5 over 2. Right? The work was there, so I know it's there. In a real situation, you'd be able to tell me, oh, I see, if I divide by 3 to the top and the bottom, I'm going to get the same fraction. Okay? Yeah. So that's what we're working on today. In your notebook, on your student side. Please copy down into your notebook, and if you want to use the same colors, it'll probably help you. 6/8 equals 3/4. You see the, oh, it's not in color. Shh, Nikes. I'll draw it on the board for you. It would help if you put it in 2 different colors. It don't have to match mine. So 6 over 8, the 6 and the 8 should be different colors. And then equals 3 over 4, the 3 and 4 should be different colors. And the 8 and the 3 should match, and the 6 and the 4 should match. This is a skill you already know how to do, right? What skill do you see, even though I haven't drawn it yet? What skill do you see, Seth? Yeah, but what are we doing? We've done it a couple times, not really done a lesson on it. Megan?
Inverting rates?
No. What do you notice about the way the colors are matched up? What are we going to do, Nicholas? Cross multiplication. Okay? It's called cross multiplication because they cross each other. Get it? They cross each other. Okay. You can always cross multiply unless there is one caveat. What's wrong? There is one caveat to this. And I want you to write this down. Cross multiplication does not work if the denominator is 0. Cross multiplication does not work if your denominator is 0. As you're writing this, someone want to explain to me why that's true. Why does cross multiplication not work if there's a denominator of 0? Julia Gill.
Because if the denominator is 0, 0 times whatever number just equals 0.
Good. So you're not going to get the right answer. So if you have denominators of 0, you can't do cross multiplication. Okay? It's an easy one. Yes?
What if both denominators are 0?
That is an imaginary number which you'll get to later in life. We don't do that this year. Nicholas.
Will it have the colors if we like, will it be shaded light?
Your example number 2 is on 57. That shaded for you the correct way? Nothing else is, though. Alright, so let's do some examples together. Bless you. I'm just going to make up some random ones, so this is going to go in your notebook, and then we'll have you practice in your textbook. So we're going to start off with just the normal random. They already gave you the proportion. You don't have to figure anything out. Okay? So you're going to see something like this. 8 over x equals... this is harder to do than I thought.
16 over 32.
This goes in your notebook.
Over 64.
No, yeah. 8 over x equals 12 over 6. Alright, so here's where the problem comes in. Can I simplify 8 over x? Can I do anything to that fraction? Can I do anything to that fraction, Cheyenne? No. So this is where cross multiplication has to come in. I have to cross multiply. It doesn't matter which one you do first, as long as you're making sure that you're doing a numerator to a denominator. I always like to start with my upper left-hand numerator, just because that's easier for me. But you don't have to. You can do it either way. 8 times 6 is? 48. Equals? 12 times x. Meg Welsh? 12x. And then you're going to algebra. So you're going to solve for x. Okay? If you can do it mentally, I'm okay with you figuring this out mentally. So x equals what? X equals what, Charlie? 4. X equals 4. Because 12 times 4 is 48. Okay? Does that make sense? Wonderful. Why don't you do A, B, and C on your own, please? Cross multiply those. It doesn't matter which way you do it, as long as you're going from numerator to denominator.